Hey everyone, welcome back. Let's continue our marble adventure. At the end of our last video, we had a claim from your friend. So half of the marbles in the bag are red. And then you decided to verify his claim. But how? So let's enter the world of hypothesis testing. So first, let's talk about the null and alternative hypothesis. The null hypothesis, which usually denoted by H0 or HO, and it states that the parameter is equal to a specific value. So in our case, if we use P to denote the proportion of red marbles in the bag, then we can set the null hypothesis for our testing of P is equal to 0.5. And the alternative hypothesis argues that the parameter differs from the value specified by HO. So it's usually denoted by HA or H1. The parameter can differ in three ways. It can be less than, it can be greater than, it can be simply just not equal to. Okay, so if it is less than, then it's called a left tail test. If it is greater than, then it's a right tail test. And if it's not equal to, then it is a two tail test. Okay. So in our case, we would choose the not equal to version. How to understand the hypothesis testing? A hypothesis testing operates on the same principles as a criminal trial. Initially, the defendant is presumed innocent. And as the trial progresses, evidence is presented. And if the evidence strongly indicates guilt, we abandon the presumption of innocence and declare the defendant guilty. If not, then we maintain the presumption of the innocence. So now we are going to assume the null hypothesis is true in our case. We take 1,000 random samples and 100 marbles each. The sample means would cluster around 0.5, and the density plot forms a bell-shaped curve due to the central limit theorem, right? And one key characteristic of the normal distribution is the 68, 95, 99.7 rule, which says that 68% of data points fall within one standard deviation of the mean, and 95% within two standard deviations, and 99.7 within three standard deviations. Therefore, if we draw a sample of 100 marbles from the bag, and the proportion of the red marbles significantly deviates from this expected mean of 0.5, then we may need to reconsider our assumption. So how do we measure the significance of the deviation? We will talk about two methods, the critical value method and the p-value method. Both methods require us to decide on a statistical significance level, which determines how much evidence we need to reject the null hypothesis. So what is a significance level? The significance level, usually denoted by alpha, is the probability that we use to determine whether an event is unusual or statistically significant. The most common ones are 0.05 and 0.01. So if our test result has a probability less than or equal to this level, under the assumption that the null hypothesis is true, then the result is sufficiently unusual for us to doubt the null hypothesis. So let's look at the critical value method. In here, the z subscript alpha refers to the z-score with an area of alpha to its right. So the area of this part is alpha. And similarly, z subscript alpha divided by 2 refers to the z-score with an area of alpha divided by 2 to its right. So for the critical method, we need to calculate a value called test statistic. In our case, the test statistic is the z-score for proportion obtained from the sample in the sampling distribution. Also, we need to determine a critical region and reject a null hypothesis if the test statistic falls in the critical region. So let's see how we calculate the test statistic. First, we calculate the critical values and we use the Q norm to find these two values. In our case, it's a two-tail test. Okay, so the critical values are -1.96 and 1.6. And the z-score is 3.8. So since 3.8 is greater than 1.96, so we rejected the null hypothesis at the 0.05 level and conclude that the proportion of the red marbles is not 50%. Next, we are going to take a look at the p-value method. So instead of checking if the test statistic falls within the critical region, we calculate the probability of observing a test statistic as extreme as or more extreme than the one calculated from our sample data, assuming that the null hypothesis is true. So what we calculate is actually the area under the curve to the left for a left tail test and the area to the right for a right tail test, and for both sides for a two-tail test. And also for a two-tail test, we can calculate the area for one side and then we double it to get the p-value because it's symmetric. Think of p-value as a how strange is this gauge. So compare the p-value to the significance level. A lower p-value indicates that your sample result is so far from what the null hypothesis predicts that it's unlikely to happen by just a random chance. If p-value is low, we reject HO. You can remember in this way. So that's calculated the p-value for our example. So because the sample means follows a distribution, a normal distribution with a mean of 0.5 and a variance of 0.0025, then we actually calculate the right side. The probability of x is greater than or equal to 0.69. And then we double it, then we get to the p-value, which is 0.00014. And because of 0.00014 is less than 0.05, we reject the null hypothesis as we did from the critical value method. So keep in mind that there's always some uncertainty. Here we take another sample of 100 marbles from the bag and it gives us 58% of red ones. And then we calculate the z-score and p-value or indicate that we fail to reject the null hypothesis and conclude that the proportion of red marble is 50%. Well, this is not true, right? Because we know that the true proportion is 0.64. So we are actually making a type 2 error, which states that we fail to reject the null hypothesis when it is false. Another error exists known as type 1 error. So type 1 error occurs when we reject the null hypothesis while it is true. So we will talk more about type 1 and type 2 error in our next video. But now I want to give you some interview questions about the hypothesis testing. One is from Facebook. The question is, say you flip a coin 10 times and observe only one head. What would be your null hypothesis and p-value for testing whether the coin is fair or not? So you can pause the video and think about it, how to solve this problem. So let p be the probability of getting a head. And the null hypothesis would be p is equal to 0.5. And the alternative hypothesis would be p is not equal to 0.5. Can we apply central limit theorem? No, because the sample size is less than 30. What can we do? So let's revisit the definition of a p-value. A p-value actually calculates the probability of observing an outcome as extreme as or more extreme than the observed data, assuming the null hypothesis is true. Okay, so let's assume that the null hypothesis is true. Then we're going to calculate the probability that we get extreme and more extreme results, and that would be our p-value, right? X is a binomial distribution, and we are actually calculating the probability of x is to 1, which means we don't have any head in the 10 flips, and the probability of x equal to 1, which means we have one head. We need to consider the extreme cases for the tail, which means that we get 9 heads and 10 heads, these two cases, okay? Why? Because when you perform a two-tail test on a set of data, you are interested in deviation from the expected means in either direction. not just the direction you observed. So we have to calculate the sum of these 4 probabilities. And then we use R to calculate them. We can calculate the probability x equal to 0 and x equal to 1, and then we double it. And then the p-value we get here is 0.02. So because 0.021 is less than 0.05, we rejected the null hypothesis at the 0.05 level and conclude that the coin is not fair. And there's another interview question that's from D.E. Shaw. It says a coin was flipped 1,000 times and 550 times it showed heads. Do you think the coin is biased? Why or why not? So the first steps, we're going to state our null and alternative hypothesis. It's actually the same as the previous question. And then in this time, because our sample size is 1,000, it's large enough so we can apply the central limit theorem. Okay, and then we can calculate the z-score and the p-value. So the z-score is 3.162 and the p-value is 0.001, and all the values indicate that we are going to reject the null hypothesis at the 0.05 level and conclude that the coin is not fair. Okay, so that concludes my video. Stay tuned for the next video. I'm going to talk about the type 1 and type 2 errors. If you find this video helpful, please like and subscribe. Thank you for watching.